Hello, scholars. Today we're going to look at another way to find the roots besides looking at the graph and looking at where it crosses the x-axis or where it has roots, or besides factoring. Another technique we can use is using just algebraic operations, specifically the square root, in order to do that. And so when we're using that technique, the two things we want to pay attention to is we want to look for equations that might that might not have the middle term, the bx term. So you could certainly do that, or if you see it in vertex form, you could certainly solve it using square roots this way as well. So those are going to be two equation forms that might be quicker, or the square root, using square roots might be a little bit more of an advantage. So simple steps here, and we're going to do a couple of examples throughout this session. The first thing we want to do is typically that when we solve equations, we want to isolate the variable, and so that means get it by itself, and then once it's in a squared, we're just going to do the inverse, which is take the square roots of both sides. So in this example, when we have x squared minus 49, which you might be able to factor also to solve it, but if we're looking at that, the first thing we want to do is to isolate the x squared. So we're going to add 49 to both sides, and then we will end up with x squared equals positive 49. And then to undo the square root, we're going to take the square root of both sides. Now when we do that, when you take the square root of a number, I have the note down there. Remember that a positive number always has two square roots, the positive and the negative of that. So in this case, it's going to be both the positive root of 49 and the negative root of 49, which really just gives us both plus or minus 7. So when we write our solution, we're going to include both of them separately, negative 7 and positive 7. So this is an example where we would have, again, two roots with this function. So we'll do a few more towards the bottom of the page here. Again, remember that any positive number always has two roots to it. So we're going to do number 2, and if you want to do some of the others, I will post the solutions to all of these in today's folder. So in number 2, we want to isolate the x squared. So in this case, we're going to add 100 to both sides. That gives us x squared equals 100. And if we take the square root, notice again, we're going to have two roots here, both positive and negative, the root of 100, which really gives us plus or minus 10. So we're going to have two roots here, positive 10 and negative 10. We're going to jump to number 3 now, and we're going to do the same thing. We can anticipate that in order to get the x squared by itself, we're going to subtract 25 from both sides, and then we have x squared is equal to negative 25. So if we take the square root of this and we look at positive and if we take the root of negative 25, notice that there's a question here. Can we take the root of a negative number? And the answer to that is no. We can't do that. Actually, we're going to say that there's no real solutions here with this, and so again, this would be the example where the parabola actually isn't crossing the x-axis at any 2 points. And so the question is, when you take the square root of a negative number, however, we say that there's no real solution, and that sort of gives us a hint that mathematically, of course, there might be something that we'll look at a little bit later with that. So more on these types of problems later, but for right now, when we take the square root of a negative number, we're looking for real solutions. We're looking where it actually will cross the x-axis. So if you run into a situation where you're trying to take the square root of a negative number, but you can't, right? You can't get a real solution from that. We can't have a real number. So again, here's just a few examples where we have more transformations. We're going to look at number 12. Number 12, if we have more transformations, we just need to take a few more steps to do that. So again, the first thing we'll do is to isolate the x squared is actually subtract 3 from both sides, and so we'll end up with 1/2 x squared equals 72. And to undo or get rid of the 1/2, we're going to multiply by 2. And if we do that, we'll end up with the with x squared equals 144. And of course 144 is a perfect square, so we end up with plus or minus 12 as our solution. So we'll take a look at the one right below it, number 14. Again, I'll post all the solutions to these in our folder if you want to try some more of those. But in this case, again, we want to start with subtracting 10 from both sides. So we end up with 25 x squared is equal to 36. And here we're going to divide both sides by 25, and we're going to just leave that 36 over 25. Notice that those are both perfect squares, especially if we anticipate taking the square root. It's better to leave that than to try to reduce fractions or make it a decimal. Because in this case, if it's 36 over 25, when we take the square root of a fraction like this, and again it's going to be both positive and negative, we can actually take the square root of the top and the bottom, as we've done in other situations, and so then this becomes positive or plus or minus 6 over 5, and we'll just leave it in fraction form. And so that way we have negative 6/5 and positive 6/5 for our two solutions here. So you can see that sometimes we'll end up with maybe a fraction or another rational number as a solution. Now it is possible that we could end up with an answer where it doesn't end up being a perfect square. Both in fraction form or just a regular perfect square. And so when a square root does not end up giving us a perfect square, notice that we will have an irrational solution or a solution where we have to keep it underneath the square root, which we've done before in other courses. And so the advice here is we're going to just leave it in radical form. So don't give a decimal answer, just simplify it if you can. So any perfect squares, we can simplify the radicals and then give that solution for that one. So we'll start with number 18 and look at a very simple example where we're going to add 8 to both sides, and we take the square root of 8, both plus and minus, and remember that the square root of 8 is not a perfect square. However, if we think about this one, you can break this up. Remember, we can break up square roots into products. So you could take the square root of 4 times the square root of 2. That is also another way to write the square root of 8. And the square root of 4 actually is a perfect square. And so you can actually simplify that then, and we write that, remember, as 2 times the square root of 2 then. And that's the simplified radical version of that. And then the solutions are both the positive and the negative answer to that. So when we're looking at, again, these other examples, we might end up with, we might end up with irrational solutions where we have to use just taking the root of it. And in this case, notice that the plus 8 is what we need to get rid of. So we're going to subtract 8 from both sides because that's the opposite. And then we'll go ahead divide by negative 3, which gives us the x squared is equal to positive 10. And if we think about that, the square root of 10 actually is simplified already. There's no perfect square. All you could do is break it up into 2 times 5, and both of those are not perfect squares. So we'll just leave it as plus or minus the square root of 10, and that would actually give us our solution. So negative square root of 10 and positive square root of 10. Again, you can imagine these are both just a little bit over 3, right? So it's a negative 3 point something and positive 3 point something. But for us, we just want the exact value for those. I also wanted to give you some examples of the types that you'd see perhaps in vertex form. And again, if we want to find the solutions to these, we can still use square roots. We don't have to multiply this out. We really can just isolate the x the way we do with other types of algebraic equations. Again, we can add 29 to both sides to start out, and that will end up with this this squared product here. And notice this binomial is squared, but really all we need to do then is take the square root to undo that. And so we'll take the square root of 4, which again happens to be a perfect square. But one of the things that we want to keep in mind now is that we actually have two different solutions. And at this point we probably want to break it into two separate equations. So notice that a number plus 8 has to be both positive 2 and negative 2. So we need two different numbers there. So the first one, x plus 8 equals positive 2, and then we're going to solve x plus 8 equals negative 2. So similar to when we did factoring, where you had to solve two different equations, we have to do that here as well, because the root has both a positive and a negative solution. So we can see that the steps to solve these are fairly straightforward. Again, we're going to have and subtract 8 from both sides. So what we end up with is two solutions. We end up with x equals negative 6 and x equals negative 10 for both of those. And we can write down both of those solutions as x equals sorry, sort of cut off the answer to that last one, but this is just we'll just walk through this second example again in vertex form. Again, we're just going to take the steps in reverse. So to get rid of that minus 37, we're going to add 37. And then we're going to head and divide both sides by 3 so that we isolate the squared term all by itself. And then notice that we're going to take the square root of both sides. And when we think of the square root of 19, that's not a perfect square. And obviously there's no perfect squares that are a factor of 19. So we'll end up with plus or minus the square root of 19. So we have a irrational number, and then we have to solve for that. So just remember that we're going to keep those two separate when we solve them. So when we solve x minus 2 equals the positive square root of 19, we're just going to add 2 to both sides. And it's typical that when we do that, we just write the 2 and we add the rational number in front, and then the radical or the square root is the second term to that. So we'll keep this as a what we refer to as a complex number. So we have rational and irrational with both of that, and that's how you'd write it. We have x, again, we add 2 to both sides, and then with the negative root of the square root of 19, so we would write then both of these as our solution, and we've got the 2 minus the square root of 19 and 2 plus the square root of 19. Again, as we write those as we would just leave them as complex numbers then. All right, so we'll just do one more like this where we have this in vertex form. And again, lots of transformations here, but the steps are really the same. We just have to isolate the x by itself. So first we have to get the squared term by itself, so we can subtract 14 from both sides, and then we'll divide by 4. And we'll have this this binomial squared, and then we can take the square root so that we can get x plus 10 by itself. And so we'll have plus or minus the square root of 3, and again that's irrational, so we'll leave that. We don't really need to simplify that too much. And then we can go ahead and split up our two solutions here. Both x plus 10 is equal to the square root of 3, and x plus 10 is equal to the negative square root of 3. So if we solve that, the steps are actually the same. We just have to subtract 10 from both sides. And again, because 10 is a rational number and the square root of 3 is an irrational, we're going to leave it as a complex number, as negative 10 plus the square root of 3. And if we will do the same thing with the other solution, we subtract 10, and again, we just typically write that out in front. You typically just write with the number first and then the 1 underneath the square root as second. And so our two solutions then, again, the order doesn't matter here, but we'll have the square root of 3. That sort of got cut off at the end there, but you can imagine where that is. So again, utilize, if you need to go back and walk through these again, you're welcome to do that. And then also utilize the help videos with each of the different types of equations.